In this video, I am going to discuss about a very special property of some figure or shapes. For some figure, if we cut them along a straight line, we get two identical half of shapes. Let's start with the equilateral triangle. If we cut it along line joining to the vertex to the middle point of the opposite side, we get two congruent triangle. And for equilateral triangle, we can draw such three lines. If there is a line about which the figure may be folded so that the two parts of the figure will coincide. In other words, we can say if there is a line about which the figure may be divided into two congruent figures, that line is called the line of symmetry of that figure. Again, this one is an equilateral triangle. We draw a line joining vertex to the middle point of the opposite side and consider this line as a mirror. Consider this black triangle is a mirror reflection of this brown one. If we consider this line as a mirror, then this black triangle and brown triangle will be congruent one, and this black part will be the reflection of the brown part. Let's see. In that case, this line is the line of symmetry. If we consider one equal part is the mirror reflection of another one, then the line of symmetry can be considered as mirror. That's why the line of symmetry is also called the reflection symmetry. Let's see it for a square. If we cut it along this vertical line, we get two identical shapes. Along this horizontal line, in that case also we get two identical shapes. If we cut it along this diagonal, the result will be same, and if we cut it along this diagonal, then also we get two congruent triangle. We know the square is a regular polygon with four sides. For a square, we have four lines of symmetry. Let's see this property for regular pentagon. We know pentagon is five-sided enclosed area. If we draw this line, we can easily divide this pentagon into two equal parts. We can draw such five lines along which we can easily divide this pentagon into two equal shapes. For regular pentagon, we have five lines of symmetry. Some figures are symmetric about some fixed line and some are not. In case of regular polygon, where side length and the angles are equal, number of sides and the number of symmetric lines are equal. For regular polygon, we can say number of sides equal to number of line of symmetry. Now consider a circle. If we cut it along this line, we can divide it into two congruent shapes. If we cut it along this horizontal line, in that case also we get two congruent shapes. If we cut it along some other line, that case we also get two identical shapes. For a circle, if we draw this vertical line, this horizontal line, or any line passing through center, we can easily divide it into two congruent shapes. Every line through the center of the circle is the line of symmetry for the circle. So, circle has unlimited number of line of symmetry. The line of symmetry for English alphabet. First, see the English alphabet. Here we see the A to Z, all the letters. For A, we can draw a line along that line we can separate this A into two equal congruent parts. That is this line, this vertical line. For B, this horizontal line. For C, this horizontal line. For D, this horizontal line. And for E, this horizontal line. And for F, there is no such line along which we can cut it into two equal shapes. For G, there is no such line. And for H, there is a vertical line, also there is a horizontal line. For I, also there is a vertical line and horizontal line. For J, there is no such line. For K, there is a line. For L, there is no such line. For M, there is a vertical line. For N, there is no such line. And for O, there is very much similar to the circle. That's why there is unlimited number of line of symmetry. For P, there is no such line. And for Q, there is no. For R, there is no. For S, there is no line. And for T, there is a vertical line. For U, there is a vertical line. For V, there is a vertical line. For W, there is a vertical line. And for X, there is a vertical line. Also, there is a horizontal line. And for Y, there is a vertical line. And for Z, there is no such line. This one is the line of symmetry for English alphabet. Now, let's see the line of symmetry for mathematical digit. We write here from 0 to 9. For 0, this one is very much similar to the circle. If we consider the 0 as similar to the circle, then there is unlimited number of line of symmetry for this 0. And for 1, there is no such line, or there is no line of symmetry. For 2, there is no line of symmetry. For 3, there is a one line of symmetry. For 4, there is no such line. For 5, there is no line of symmetry. For 6, there is no line of symmetry. For 7, there is no line of symmetry. And for 8, there is two line of symmetry. One is vertical and one is horizontal. And for 9, there is no line of symmetry.